Hello, hello. Should be live. I'm going to wait a minute or two while people are rolling in. If you're already kind of joining, make sure to say hello in the chat. Say hello here. And then, also let me just make sure. I'm going to bring up the stream in one other place just to make sure that we are live. And again, as people are joining in or as you're joining in, say hello. It's always fun to hear where people are watching from as well. So if you want to include that, that'd be pretty cool. And if you want to add a little extra info, maybe why are you interested in building ML pipelines? And is there something like you've run into before or something you want to get out of today's session? Let me know. Okay, cool. Got the other stream up. Okay, awesome. So again, while people are rolling in here, I will share my screen. Let me get set up here to present. Also, while you're joining, the links for everything should be in the description. So also, if you're watching this as a recording later, you should be able to find the links that you need to follow along in the description. But I will also share them in the chat here. So number one thing you'll probably want to do is create a Union account if you haven't already. It should be the only account that we really need to run everything today. You do need a GitHub account to sign up for that. So technically you need a GitHub account. And then also, I guess we will be using Google Colab. I'm assuming most of you will have a Google account as well. And we'll get to that in a minute. And then also, if you want to go ahead and poke around at the code, I know I like to do that going to sessions sometimes. That's the GitHub repo we'll be running from. And there's a Open in Colab button that you can click. That's going to open the kind of tutorial that will follow along in a link like this or a page like this. And if you haven't used Google Colab before, it's a way of Google's way of hosting a Jupyter notebook and gives you a little compute environment there. So we're going to be running code in there today. And again, I know I see people kind of still joining in, so we'll wait a minute. But if you want to get set up, those are probably the two things to do. And welcome, everyone. I see people coming in, people joining. So again, as you're joining too, feel free to say hello in the chat and maybe where you're watching from. And if you have anything that you want to add around why you're interested in building ML pipelines, that's always fun to hear as well. See more people joining. I think now's the time, a few minutes in. People are opening up the live link. So again, welcome everyone. Links to follow along again, because this is going to be a workshop. I'm going to go through some slides, and then we're going to go into code. So slides are going to kind of set up some of the concepts here, make sure everyone's kind of on the same page. Also allows kind of people to give them time to join in and settle in a little bit, and then we'll be going into the hands-on code part. So links are in the description to follow along. And also I'll share these again because I see more people joining in. Sign up for free there. It can take 3 to 5 minutes to process. You should get an email. If it doesn't go through for some reason, let me know. And I can also see if I can push you through. So sometimes if your GitHub profile is super new or it doesn't have some information there, it might get flagged. And then also I will share. So for the workshop, keep the questions in the live chat here on YouTube. But if you have questions later, there's a Slack group you can join that's pretty active. And we talk about stuff that's not just related to Flyte, which Flyte is the open source orchestration platform that Union's built on. We'll talk about that a little bit later too. But it's a pretty active community in there. We do a lot more than just talk about Flyte. So if you want to join and talk about ML or join the AI book club, there's a lot going on there that you can check out. All right, cool. I see quite a few people in here now. So again, links are in the description. I also shared things in the chat. And also, if someone wants to say hello in the chat, it's always great. Put where you're watching from, why you're interested in machine learning pipelines. No one has said anything in there yet, but I see quite a few people here. So somebody should say hello in the chat and let me know that you can hear and see me. All right, so I'm going to get started on the slides. Again, if you just joined, I'm going to do some slides, and then we're going to go and do a hands-on kind of code portion where we'll actually go build a machine learning pipeline. If you've never done machine learning before, that's okay. I'll kind of explain what's going on. And we're actually going to be using kind of a simple model today, but what we're going to learn can um, transfer to more complex workflows. So I'm actually doing a workshop in a few weeks on fine-tuning a large language model. And so a lot of the concepts here kind of transfer to that. But if you also want to register for that, I think I have that in the links as well. All right, so, oh yeah, knowing some Python will be helpful, but again, if you've never done a lot of Python, don't worry. You'll be able to run all the code today, and you'll actually come away with this pipeline, which is cool. It has a lot of features that are actually like basically you'll be building a production grade pipeline today, even if the kind of model itself is maybe relatively simple to some other things you'd see in production. All right, cool. Somebody actually said you can hear me. Thank you so much for letting me know in the chat. Oh, and also, right before we go, one more time, I'm going to share these links in. I forgot I shared them in the YouTube live stream. I'm going to share them real quick in the LinkedIn live stream. So just there's one sign up link and the GitHub link. And again, like I said, I know I like to kind of poke around at the code, so feel free to open those up right now. But you'll have a few minutes before we get to the hands-on code part. All right. Okay. I'm going to go now on the slides. Let me know too, if you have questions, kind of as we're going. I'm going to keep an eye on the chat. I might not get to everything immediately. And then also, if I do miss your question, I apologize. Just feel free to ask it again. And I'll stick around at the end to try to maybe get anything that I catch up on anything I didn't get to during the workshop itself. So a tiny bit about me. My name is Sage Elliott. I work at Union. You can find us at union.ai, and we'll see kind of this stuff in action, but we're a AI orchestration and inference platform. I live in Seattle. Again, if people want to put where they're watching from, it's always fun to hear about. I think someone said they're watching from India. Awesome to have you here. It's really fun to see people all over the world. I run an AI book club, which you can also find in the Slack channel I shared earlier. So we've been reading a new AI book every single month and discussing it online. It's been really fun. We did 12 last year. I think we're going to do the same this year. I've learned a lot, and it's the most I've ever read technical books in a row. And then previously done a lot of work in computer vision. And actually, right before joining Union, I worked at a ML monitoring and evaluation company. Pretty interesting for times with LMs when LMs came out, and figuring out how to evaluate them. That's a really interesting concept that I'll probably dive deeper in another workshop or talk later. And then also have a background in doing hardware and IoT and a little bit of robotics, and then kind of been in the ML ops space now for several years. If you want to connect with me, you can find me on LinkedIn, Sage Elliott. I will also share this link in the chat though. And then also, again, the Slack channel is going to be a good place to ask questions to me later, or just other people in general in the ML community. But I'm in there and pretty active in there, so join that if you're interested as well. Cool, and I see people are joining from Dallas and Portland, Oregon. Awesome, I love Portland. I haven't been to Dallas yet. I live pretty close to Portland, so I've gone there quite a bit. I'm actually going there in a few weeks to talk at Pi Cascades, which is the Pacific Northwest kind of regional PyCon, which is cool. I'm actually this picture is from me giving a kind of a first run of the talk I'm going to be talking on, which is why you should build a robot, and it's kind of an introduction to MicroPython and microcontrollers. So if you've never done stuff with hardware, it kind of breaks that barrier down, and it's pretty fun. About you, again, I saw a lot more people join since we started the slides. So again, we're doing some slides, and then we'll be going on to the hands-on portion, and there should be links in the description. You should also be able to find them in the chat. But also, for those new people who just joined in, you haven't said hello in the chat yet, this is a great opportunity. Where are you watching from? What are you working on? And maybe if you want to add, why are you interested in ML pipelines? It's always fun to kind of hear like what people have done so far or what you haven't done. And then again, I'll share this one more time. I think it's the last link I shared anyway. But there's also an introductions channel in there. So if you want to give more of a permanent introduction to the ML community, that's a great place to do it. I won't see it right now until after the workshop, though. So put in the chat maybe what you're building with machine learning, or what you want to build with machine learning, or what you've done. it's kind of fun to see people's experiences and practices so far. Someone said to say hello to Niels, who's our chief of ML. Will do. Someone said they want to see MLOps in action. Awesome. This should be a great place if you haven't done a lot of that before. It should be a good introduction. Someone said they're currently building enterprise AI solutions at M37 Labs. I'll have to check that out. That sounds cool. Also, yeah, if you have any insights or things like you've run into, like when you're building these enterprise AI solutions and you've had bottlenecks or any types of issues, if you want to share those in the chat, it's always kind of interesting to see what people have had challenges with, because there's a whole bunch when you're trying to implement stuff like at scale in enterprises, especially with LMs, and it's new and a lot of people are figuring stuff out. All right, so kind of a quick intro of MLOps, or now you might be hearing the term LLM ops, which is MLOps, but specific to LMs. And today we're not using LMs. We will be in another workshop though. But MLOps is kind of the set of practices and tools that aim to deploy, monitor, and maintain machine learning models in production. And I kind of like to think of reliably and efficiently. It's like kind of why you want to implement a good MLOps infrastructure. So this is a very basic pipeline. You might have seen something like this. Has anyone built a pipeline before that maybe has some of these steps involved? And this is scaled back. There's probably going to be way more steps in your actual production pipeline. But typically every pipeline is going to have something like this, where you're going to be collecting data. Usually you're going to be doing transforms or pre-processing on that data as well. So it'd be another step. Then you're going to train a model with that data. Then you'll have to evaluate that model to see if it's, performing well or looks like it's good enough to put in production. Sometimes that's like training, that can take a long time, doing a lot of hyperparameter optimization, etc. And then you're going to move that model somewhere and ship it or deploy it. And there's different ways the different ways of deploying models or shipping models. So it really depends on your application. This could be, deploying a model on a web endpoint. It could be moving a model to a piece of hardware and having it live on the edge. Once that happens, then you typically want to have some form of monitoring. There's a lot of great tools now out there for that. Like I mentioned, that's kind of the field I worked in previously for a few years. And it's really interesting because, you can't just put a machine learning model out there and then expect it to be good forever. Things happen like data drift, where the data no longer matches the data that it was trained on. So your model's not performing as well. And when that happens, you usually want it to have data collection of production data. And then you're going to kind of perform this loop again, where you take that new data from production, train another model with it, evaluate it, ship it, and maybe actually even do A/B testing between the old model and the new model. And then you just kind of start this circle of life for ML models. Some people call it the data flywheel, ML lifecycle. And again, this is a pretty stripped down version. But has anyone ever done something like that? Have you ever put a model in production and then something happened, like new data came in that it wasn't trained on and it just started performing weird? And then I mentioned LM ops. So with LMs, there's a lot more that you might want to consider as well, like vector databases. How do you handle those queries? Guardrails is a big thing. You don't want just any query to go through. And prompt management. So there's and prompt management, and also parsing responses. So there's just a whole bunch to kind of think about when you're building your pipeline. And this is like a stripped down version. There are many tools to make this easier. So for all these steps we talked about, there's probably a really good tool to help with it. Like obviously training a model, you might use PyTorch or scikit-learn or Keras. That makes it way easier. But to kind of tie all these things together, you need a compute platform. And if you want to do this at scale, reproducible across a whole bunch of teams, you need to build a reliable workflow. So these workflows are kind of the core of those pipelines. So this is a little sample workflow that we're actually going to build today. We're going to download a data set, process that data and visualize it, train a model, evaluate the model, and then we'll do another little kind of test prediction. And then we'll actually see how we can interact and kind of deploy this model in a couple ways as well. But when you're implementing this in like a big enterprise or organization, you want to make sure it's reliable and efficient. So you want, scalability. Again, it depends on your use case, but you want to be able to scale up to handle those AI workloads. A lot of times you have really large data sets and complex models. We work a lot of self-driving car companies. So as you can imagine, their data sets are quite big. You want reproducibility. So every time you run that workflow, you want it to be in the same environment. So every single task that we're going to run on today is going to be in a containerized environment. So it's going to load in the same environment every single time. You want versioning. So every time you run this workflow, maybe you've changed hyperparameters on your ML model. Maybe you've changed the data set. You're tweaking several things here. You want to be able to track not just your code like you do with GitHub, but every time you run a workflow, you want to be able to track the data that went in, maybe the lineage of that data, what hyperparameters you used for the machine learning model. You want those models versioned. And sometimes this is kind of required in fields where you need to audit those things like healthcare and some financial situations and maybe insurance, where you actually want to go back and say, well, why did my model perform this way? And I have like a lineage of all the data that it was trained on. You want to improve efficiency. So you want to allow your data scientists or ML engineers, AI engineers to focus on like actually creating the tasks here, maybe not messing around with infrastructure as much. And we'll see, we're going to use a declarative infrastructure. So write in your Python code, you'll be able to say like what you want these tasks to run on. And it really allows AI engineers to put stuff out in either in production or do experimentation way faster. And you don't have to go through like an ops person once it's set up. And then with this, you also get a lot of optimization on resource usage, reducing usually kind of overall cost. But a lot of the cost also can come from people's times. And just to hammer on a couple of points that when I talk with people who adopt a more modern MLOps infrastructure, some things that really stand out to me that save them a lot of time or money, and this one sounds obvious, is optimizing for local and cloud development. So maybe your team isn't set up this way. Maybe you're using some sort of pipeline tool where you could only run in the cloud that it was on. But being able to utilize your local compute resources over just the cloud for doing testing and debugging, one, saves a lot of time. I think that's the big thing. It can save money too if you're spinning up a lot of resources every time. But for example, if you run something and then you have to wait for containers to spin up and then it fails a couple tasks down, you can save so much time by finding that bug locally and not waiting for everything to spin up and then tracing that bug in the cloud. When you're selecting a tool or kind of creating how your team works, I think optimizing for local development is a huge time saver. Leveraging caching in the pipeline. So we'll also see this in action today where, in this case, we're running a workflow that has a data set. Maybe you would realistically break this workflow up in different ways. But for example, we're loading in a data set here, processing that data, and then training the model. If we were rerunning this workflow every single time, we don't really necessarily need to re-download the data or pre-process it if it's the same data set. So we can enable caching and then allows us just to run the tasks that we want using cached outputs already. Task level resource management and containerization. This is a big one too. So, historically, people might have been running this workflow on kind of one compute cluster where maybe you need a GPU to train the model, but the downloading the data set takes like a couple hours. That's a lot of time maybe to run or pay for that GPU or be hogging that GPU from other people that could be using it. So with task level resources, every single task you define like what you want for that. So for downloading the data set, we might just want some CPUs. Maybe it's a lower amount. Maybe it's just a little bit of memory because we're just downloading something. We're not even reading it into our memory yet. And then for our training task, we might want way more compute. Maybe we need more CPUs, way more memory to read that data in, and GPUs. So you can define every single task here gets its own compute and it's containerized. So we'll see this in action again today too, and how to define this. And then this is also kind of where that declarative infrastructure piece comes in, where when you're defining these tasks as an AI engineer, you can actually just put it in code. And again, we'll see this in action, but it's like a decorator above your Python function. You say, what kind of compute do I want to run this task on? And then also, this might sound a little obvious if you've used languages with like type safety before on compiling, where this just kind of reduces or mitigates errors quicker with type safety. So we'll see this in action too. We kind of force with union or Flyte when you define a task, the type of data coming into it and the type of data leaving it, you have to define. And if you kind of mess up how that's being done inside that task, it'll warn you when it compiles. So way quicker feedback. So today we're going to be using Union. I think people might have already been signing up. If not, I'll share the link again. There's a free sign up. You get $30 of cloud credit. You don't even have to provide your credit card or anything like that. And then with this, we'll get a whole kind of nice UI. We'll get a Python SDK. It's built on this open source called Flyte, which you can check out, called Flyte. It's spelled that way because it started as the ML orchestration tool inside Lyft, and then it became open source. It's now by the Linux Foundation, and then Union uses that as the orchestration part of the tool, and then it has other features built on top of it as well. So we'll get declarative, infrastructure, versioning, caching, type safety. There's a pretty comprehensive plugin ecosystem, but also a lot of things just work if you can use Python with it. And then it's scalable. It's built on top of Kubernetes, and we'll see the user interface and SDK here in action here in a minute. And then also just to kind of recap, have people done machine learning here before? It sounded like a few people have. Has anyone never done machine learning? Let me know in the chat. That's okay too. For today, we're using a fairly simple model. Like I had mentioned, what we're going to see is more about building the pipeline today. And what we see in action can transfer to much more complex models. For today, we're just going to use kind of a hello world example and use a k nearest neighbors model, which k is a variable. You can give that an integer. So in this case, like this new black dot here this black dot's a new piece of data. And then the k is 4 in this case. So it's looking at the closest 4 neighbors and then making a decision of what class this belongs to. So 3 of them are this versicolor, and it would predict that it belongs to versicolor. And we're going to use scikit-learn as a library. And then just kind of as a high level, you can think of machine learning as a function that you pass in data. It's going to learn patterns from that. And you can pass in new data it's never seen before. See how it relates to those patterns it learned from a training data set, and then give you a prediction of, like, in this case, what class something belongs to. And that's enough slides. So let's go ahead and get to building our pipeline. And I'll share these links again. They should be in the description as well. There's GitHub, and then this sign up link. You can also get to the sign up by going to union.ai and clicking the sign up button in like the upper right. And like I mentioned, it might take a few minutes for you to get onboarded. And if you never get a thing, let me know in chat. I can see if I can push you through. If I can't right now, I can definitely get you onboarded after the workshop. Like I mentioned, sometimes it might flag a GitHub account for various reasons. And another good place to post that would be in the community Slack that I shared. So if I don't get to it during the workshop, we can definitely get you onboarded after. All right, so open up the GitHub link, and you should get a page that looks like this. What you want to do is hit this Open in Colab button. This is going to be our kind of temporary computer environment that we're going to run the code from right now. And I'll also actually share the direct Colab link in the chat as well. Let me zoom in here probably a little bit. Also, for some reason, I know I made some updates to this, but when I open a Colab, it has like a cached old version. Yours might not be cached and might look normal. Mine looks like it has some old things in it, but it should be okay. I think the workshop will run regardless because we're going to clone down the non-cache version. So yeah, I'm not sure why it looks a little different here, but this has some text. It's just kind of to be its own walkthrough too. So if you came here not during the workshop, you could learn a little bit about this. But we're going to see how to make all the things that we just kind of talked about. So this is one of the things that was supposed to be fixed. I'm going to fix it real quick on my end. You don't have to do this just for display reasons here. So we're going to see how to build the reproducible AI workflows. We're going to see the versioning of code and artifacts. So like the model in this case and data. We'll see data caching. We'll see the declarative infrastructure, artifact management for models of data, like I mentioned, container image builders. Actually, because we have to have containers for each of those tasks, we're actually going to see a cool way to do this in Python using Flyte and Union, where you can define it in Python and then actually just have it build a container for you. So if you don't like messing around with Docker containers, this is great. It makes it really easy. And then we'll see something called actors, which is a new Union feature that's a long-running stateful container that we can actually kind of use for serving our model in a way. And to get these benefits, like I mentioned in code, you'll see, like we'll actually be programming this here. We can actually look at the code here in a little bit too of what be running, but you'll see things like this where we have a Python function that's doing a task in our data pipeline. In this case, this is called download data. So we'd expect it's downloading some sort of data, and it's going to be outputting a data frame. You'll see above it, we have this task decorator. That's a union feature here, where this is now becoming one of those nodes in our workflow. And I was going to say, I was going to show the workflow. Give me 1 second. For some reason, I exited out. So every single node in our workflow is a task. Let me get this up. And you'll be able to open your own version of this here in a minute. But we are going to build a workflow that looks like this today. And every single task here or node here is a task. And we define that with this task decorator. And then we declare like kind of how we want this task to be run. So do we want caching? So for downloading data, we might. That's the thing I mentioned where it runs once, and then we can kind of save the output state to reuse in another task or workflow. You can give it a version, so you can update the cache if you have different types of data in there. We're going to point to a container image. Again, every single task is containerized, and I'll show you how this image is made in a minute, but we're saying this is the environment we want this task to run in. And then we're going to say the compute resources we want it to run on. So here, we're just saying 2 CPUs and 2 gigabytes of memory. We don't need much to download the data. But then our next task, we can see this is training a model, and we're upping the compute resources. We want way more memory, and we want a GPU in this case. And you can actually select specific accelerator types in your cluster as well. So on serverless, we have, I think it's T4s, L4s, and A100s right now. We'll probably have more types in the future, but you can actually select specific ones. I think if you just do GPU just equal to 1, it's going to give you a T4 by default, I believe. And then so you can see that this makes it really easy for you to declare it. And then you're writing Python functions like you kind of normally would. And then you can run these workflows, and the workflows designate how these tasks kind of get put together and the data flow between them. So here we're going to have our download iris data set, which is going to download a data set. We're going to process that data set. We're also going to visualize this data when we process it. So you can click on this little node. Again, you'll get your own here in a second, but I'll just kind of show what we're going to build, and then we'll go into the code. So we can click on this thing called deck. This opens up visualizations, and I have a metrics tab that I created here. And this is a pair plot of our data set. So you can embed any visualization or kind of anything that can be turned into HTML or Markdown here, including interactive things like Plotly, which is really cool. And then we are taking our data, we're training a model, we're going to evaluate our model. We have the evaluation metrics here, which is using classification report. And then we have another kind of prediction step here. So we can pass in new data and see how it performs on maybe some data that looks like crazier than our evaluation or training data set. So this is going to be the pipeline we're going to build. And for every single task, just keep in mind, we get to kind of define how it behaves with this decorator on top. So let's go ahead and go down. We can run this cell. I should have had you run this while I was explaining all that probably. Oh, one thing I'd like to do, so you can run this without making a copy. One thing I do like to do is save a copy in Drive. This will give you your very own copy that you can edit text or code directly in there. I go back to it, and you'll have that version saved. Otherwise, you can run it without making a copy. I kind of like to make my own copy when I run these things. So now I'm going to scroll down. We're going to run this. What this is doing is it's seeing if it's in Google Colab. If it is, it's going to clone that repo that we were just at, and then it's going to change directories into the repo, and then it's going to pip install libraries from the requirements.txt. So while it's pip installing, I'll show you kind of, usually I put code kind of in line in code cells for a lot of workshops. I'm changing it up this time, and I kind of wrote better, maybe cleaner code, like kind of how I maybe normally would, putting something in production. So that means I made like Python folder, or I made folders with different .py files in it. And to access those in the notebook, you can click this little folder icon on the left. And then you can see there's folders now in here. This is the repo that we just cloned. So for example, this is the requirements.txt that it's downloading files from right now, or libraries from. So I can double click that, and it'll open this over in this tab here. So for this workshop, most of the stuff that we're going to be running, and you don't have to open this up if you don't want to. I'm just letting you know where it is if you kind of want to poke around with it. We have tasks and workflows. So tasks can be broken up into different files. Maybe I broke them up, like you could break them up in any way you want, really. I have one called data. So these are all kind of the data tasks. If I pull this out, again, we'll go deeper into this when we run it. But you can see here, I have my task set up to like download the data, process the data, etc. And then I have them for training and prediction and evaluation. So just letting you know where they are right now if you want to go poke around with them. You can also go back to the GitHub repo and go look at the code in there if you want, or if you're running this locally, it's easier to find in your text editor. But you can go into the repo and go explore in tasks and workflows if you want as well. But just letting you know, I'm gonna probably be pulling them up in the collab like you're seeing here, and hopefully that's gonna work for this workshop. Like I said, usually I kind of put it in line, but I'm playing around with kind of a different format today. So my libraries are installed, and hopefully you are already signed up for Union Serverless. If not, do so now. But if you are, go ahead and run this code cell. So we're saying Union create login serverless and authenticate device flow. And then you'll get this URL. I'm zoomed in, so it's kind of hard to see, but I have this URL. I should be able to click on it, and I hit next. And then it should just take a second or a few seconds, and I should be able to be authenticated. Cool. And I am. I'm logged into serverless. So again, I've mentioned serverless quite a bit, and that's what we're running today, where I said you get the free sign up. Technically, it's in beta, but we have a bring your own cloud version that you can check out as well. So if you're actually serious about building an enterprise pipeline and you kind of like what you saw today, there's another version that's like built for enterprises and isn't in beta. So it's even more stable and has some other features that aren't in serverless right now. So first, let's create our very simple workflow. So we've kind of saw what this looks like for code. We kind of saw what we're going to go ahead and build. First thing, let's create a really simple workflow. I'm going to scroll down here and go ahead and run this. And what this is actually going to do, this isn't part of Union or Flyte. This is a thing inside Jupyter Notebooks where we're using this write file magic function, and it's going to take the Python code down here and create a file with this name. So simple workflow.py is what this means. And now we have the simple workflow.py. And again, for the other ones, we just clone them and download them. So for more complex workflows, we're going to open them up in these .py folders. I'll get rid of that for now. And I should also mention, we just came out with a new feature in Flyte, and I need to update this to reflect it. We have a cool thing where instead of writing to a .py file, you actually can register tasks and workflows directly in notebook cell. So if you actually want to build production grade ML pipelines and workflows, you can do that directly in Jupyter Notebooks now. And that's kind of a cool feature to check out. I need to update this later. So there's some slight changes you would do to this to make that work. But this works for our demo example. So now we have this workflow, so we have tasks. We didn't define anything special in here yet, like container image or caching. We'll do that in our other ones. This is like the simplest workflow you can build. And we can see that under that, we have a Python function, and it's just taking in a name, which is a string. It's taking a variable, which is a string. So again, everything has to be typed here. So we say name, it's going to be a string, and it's going to output a string. So we take in that variable, and then we're just going to say hello name. It's kind of like a hello world workflow here. And then a workflow, in this case, just contains that task. Normally, you would have more than one task, or a lot of times you'd have more than one task. And it's going to take in that name, and then it outputs a string as well. So let's run this locally first. So like I mentioned, we can run locally and remotely in our ML pipeline. So here it says hello union.ai, and then let's run this remotely. And if you were able to log in to serverless here, this should take a few seconds. And instead of running locally here, now it's going to be spinning up a container in the Union Compute platform. So I'm going to click on this link. We'll get a little workflow here, which just has one task. So it's just one node. You can see it's working. It's spinning up a container, and then it's going to print that hello world. So I'm going to click on this. And now I can see some stuff about our task here, or workflow. So I can see the input to this task was that string I passed down, which is union remote. The output was hello union remote. And if I want to, I can rerun this task directly from the UI or rerun the workflow. So I'm going to hit relaunch on the whole workflow here. And you can see I have that parameter that we set up when we created the workflow accessible right in the UI. This is kind of cool if you're doing a lot of experimentation and you're changing like things like hyperparameters, or maybe you're testing different models out. You can change all that just from this like launch form here directly in the UI. So again, other people in your org could have access to this too, and they want to change out like what would happen if I try this hyperparameter, or again, you could have strings that it takes in and it changes the data set or changes the model types. So here I'll say hello workshop. If I could type hello workshop, and I'll relaunch, and now we have our this workflow running again. And again, you'll see that this has a version string here. So every time we run this workflow, it's a version and kind of all logged of everything that happened here. So then our input was workshop, and now we have this output. And then while we're here, a little bit more about the UI navigation. You can click this little home icon, the union button up here. You'll see there's probably 2 project folders for you right now. You can create new project folders. So if you have large projects and you don't want to just have them live in default or system, you can do that. Default is where everything is going to go by default, as the name implies. So we can click in, and you can see I have a whole bunch of runs in mine. Yours should look probably much more empty. Maybe have 2 if you were following along here. But I'll go to executions, and we'll see these are all the executions, and these are the last 2 that we just did with that simple workflow. And I can go click in and again have access to all that data of like what happened, what was the input, what was the output for every single execution here. And we'll see this maybe in action later, but you can also view utilization. I think it requires 30 seconds or something to actually log it. Our workflow was so quick that it wasn't logged here, but this is a cool way to see the memory that was allocated, the CPU that was allocated, and GPUs if you have them. You can see what was allocated and what was actually used. And so if you over allocate, you can actually go and tune your resources down and not pay for them every time you spit it up. So that was the simplest workflow. Let me see. I missed the chat, or I missed something in chat. Someone said, running locally, do you need to run workflow? I'm not sure what you meant by that. Hopefully it worked for you. Running locally is this cell. And what we're doing is saying union run, and then we're calling the Python file where our workflow lives. And then main was the name of our workflow. So if we wanted to run a different workflow from the same Python file, you would just call that here. And we'll see this in action with our more complex pipeline. And then this is the variable that we need it to pass in. And you could set this as a default variable, like in Python, name or whatever. And then you wouldn't have to, then it wouldn't be required to pass in. But you can also see, like with the workflow, sometimes if I've built a more complex one that expects inputs, you can then call help on that workflow, and it'll tell you what parameters are required to be passed in. Was anyone able to run this that's following along? Always good for me to double check. Like people were able to sign up, you were able to access the dashboard. If you did, then everything else should run very smoothly. Our more complex workflow that we're going to build right after this should run for you. But just want to make sure, was anyone able to sign up and get onboarded and then run this? Get authenticated into the notebook. Well, people are hopefully going to reply there. I'm going to get a sip of tea. No one said yes, which hopefully some people were able to run this. If you are following along, I know some people also like to just watch. That's fine too. Someone said they have been able to follow along so far. Awesome. Thank you. Yeah, it's always good for me to check. And you never know, something happens and something went down somewhere. All right. So we created our simple workflow, our little hello world. Now let's go build that much more complex pipeline that I kind of showed earlier. Where again, we're going to download the data. We're going to split the data into test and training and visualize our data. Then we're going to train I have a random forest here. We're actually going to train a KNN model today. But you could update it to train a random forest pretty easily. And then we're going to evaluate the model. We're going to save the model as an artifact so that we can actually use it in other workflows later. And this is going to be important kind of for putting our model in production and kind of serving it in a way for batch inference that we'll see today. Oh, and then I actually had this note because I usually don't break it up, but I actually did break up our workflows today, or actually no, sorry. So we're building one workflow that's going to download data and train a model. And this note's actually saying that sometimes if you have really complex workflows, you might have more than just one to like download the data and train a model. You might have like a data engineering team and an ML engineering team, and you want to be able to pass off data from your data team to your ML team. And this is where artifacts comes in and makes it really easy. And we'll see again a little bit of that in action later too. But just want to note that like today our workflow is kind of all together. But again, with your team, depending on what your team looks like, you might have it broken up a little bit differently. All right, so you can navigate to the workflows.py, and then there is a train iris classification function or task in there, or sorry, workflow in this case, that's gonna a collection of tasks. And then also you can go to the task folder, and that will contain the tasks that are part of the workflows. And then also the container.py contains the specifications for our environment that we want to run these in. So I'm going to go ahead and run this, and then I'm going to go into the code if that's okay with everyone. So you should be able to run this. We're saying union run remote. We're looking for our workflows.py file, which lives under workflows. And so you could also break up these workflows into separate files. Instead of just having a workflows.py, you could have like a training.py, however you want to break it up to. And then I'm calling this specific workflow, which is train iris classification. And if I open up this link, so first of all, actually, if you're running this for the first time, it'll say something like building image. That should just take a few minutes, probably at the most, because our image doesn't contain any big libraries today. It just has scikit-learn and a couple other things. Once that happens and the build image is successful, then you'll get this link. So if you click on the link you have right this minute, it might take you to the building of the container. And then you'll get this second link, which if you click on that when it's ready, will be your workflow. And you can see that mine is running. And part of the reason why mine ran so fast is I've run it before, and we enabled caching on that download data set. So every time I run this workflow, it's not going to download the data set again because I don't need it. And then I process that data, train the model, evaluate it, and then run another little batch prediction. Again, we'll see the code for this here in a second. But if you run it, that's what you should get. And I'm going to try to show the code directly in Colab. Let me know if this works or doesn't work for you. I do have it open in a VS Code as well if it does end up being a little bit better. So first, let's go to the workflows folder and go to the workflows.py. I'm going to double click on this. And all right, I will see. Okay, I can drag this over a little bit more. I'll talk about just the libraries as we use them, not on the imports. One thing you'll see, we're declaring something called an artifact here. So this allows us to classify a piece of data. It could be, in this case, it's a machine learning model, but it can also be a data set. We'll see that with data sets here in a second too. And then I can track now this model in Union. I can see the lineage for it. I can query for it, pass it between workflows really easily. Again, we'll kind of see this in action. Now we have our first workflow in here, which is the train iris classification, the one that we just ran. You can pass in these parameters to it. So by default, the number of nearest neighbors is going to be 3, but it's parameterized. So in that launch form, every time we launch it, we could change it and kind of quickly do experimentation. And then we have this kind of test data that we're going to pass in that is going to perform a prediction on. And this is kind of maybe similar to what is in the actual data set, but I like to do this sometimes as an extra step in my pipeline to give it some data that maybe isn't in the evaluation data set or in the training data set and see how it performs. So you could put like negative values here, really high values, see what happens. Spoiler alert, we'll do some of that later. And maybe you already have a guess with how that works with k nearest neighbors. If not, we'll see it. And then we have our tasks here. So the first task I'm calling is download iris dataset. And this is defined in our task folder. I'll go pull those up here in a second, but first we'll just look at the flow of data here. So I'm going to need data from that task. And then we have this pre-processed data or processed data, and it's getting a test and train data set from that. And it's taking in the data that we pulled from there. Then we're getting our model. This is going to be our trained model here. So we're passing in the training data set and the number of nearest neighbors here. We're going to train a model on that. Then we'll evaluate the model with the test data set. And then we are doing that extra prediction step here. And then our whole workflow does return the model here. So now I'm going to go look at those tasks. So again, I'm hitting the folder icon here. And let's go look at tasks. The first ones are in data. So I'll click into there. Again, we're defining some artifacts because we want to track, in this case, our iris test data set and iris training data set, and then the raw data set. So we could go query these specific versions anytime we want. And then we have our first task here, which is downloading the iris data set. If you're not familiar with the iris data set, it's kind of a hello world of machine learning data sets where it has 3 classes of flowers and 4 features. So it's the petal length and width, and the sepal length and width, and the sepal is kind of like an under flower, or like a under petal on the flower, like on the bottom. So just with those measurements, you can kind of predict what flower it belongs to. So now we're going to download our data set. For our task, we want caching enabled. So it's not going to rerun this every time we run the workflow. Again, our data set's kind of light today, but this makes a big difference if you have like a really large data set full of images or video for like computer vision. We give it a cache version, so we could update this and roll back to different versions of the caching. We have a container image, and this container image, I'll bring up in a second here, but we're saying is equal to image, which we're actually importing from that containers.py. I'll pull it up after we read through the rest of this task. And then for the resources in this task specifically, we just want 2 CPUs and 2 gigabytes of memory. It's a pretty lightweight task. We don't need any GPUs here. Then this is our actual Python function of what the task is going to do. So we're going to say download iris.py. That's the function we're defining. And then we have to give it a type. And if you're not familiar with this annotated type in Python, it allows us to kind of add metadata to typing. So we're expecting a pandas data frame, but we also expect it to be a specific artifact that we defined up here. So we can keep track of this. And that's how kind of artifacts are defined right now in Union. And we'll see what this looks like in the UI and how to pull them into other workflows later. Then we're saying iris is equal to load iris, which is a function from scikit-learn that contains that data set. And then we're going to create the pandas data frame from the iris data and the iris features. And we're going to add the target, the actual classes onto there as well. And then we're going to return the raw iris data artifact. And before I go into the next function, let me go ahead and bring up this containers.py. So I have my environments kind of defined in this containers.py file. Again, it's done in Python, so you can put them in different files. And we're using something called image spec, which is a feature of Flyte and Union, where you can actually define all the packages directly in Python here. What I'm doing instead is reading them from the requirements.txt. You can also put in other environment variables here, like versions of CUDA. Do you want it to apt-get install anything for you? You just define it right in your code here. And then we're assigning this a variable image, and then I can just import that into the task folder. And when a task is trying to use it, go back to that data task. When a task is trying to use it here, Union will look and see, does that image already exist? And if not, then it's going to build it, which happened to you if you ran it before and it was building that image. Otherwise, I'll say, oh, this image already exists. I'm going to go ahead and use it and pull it into the container. So now let's look at our next task, which is the process and visualize the data set. The only different thing here in our task is, let's see, are we using something different? I guess not in this one. I thought I had something called a flight deck, but I might have forgot to put it in this. So I think it's in another task, and we'll talk about it later, but it's a way to embed the visualizations that I had pulled up. Here, we're defining our process data task, and we're taking in that data frame from our download data, and we're creating 2 artifacts from it with that annotated type. And then we are just doing a train test split on the data frame, and we're going to get train data frame and test data frame returned from it, passing in that data frame. Our test data is going to be 20%, so that means 80% of the data we're going to save for training. Random state is just kind of how those get shuffled. You can give this a different seed, but you can come back and see what that state looks like with the seed. And then stratify just means we're going to try to get an even cut of all the different classes, so it's not overly sampled on a single one of them. Then we're going to create something called a pair plot, and that's kind of the visualization I showed earlier that had the different variations of scatter plots in it. And we should be able to see this later if this works, because I see I might have made a mistake here, so we'll see. All right, so and then we are appending that to our deck. So we're creating a metrics deck, and that's the thing I'm slightly confused about, because I think I forgot to initialize it up here. Oh, no, okay, we did. I don't know. My brain was just reading this as cache. So we enabled a deck, and that was the thing where in our execution, we click on this, we have this deck button. That's where you can embed visualizations. And so this is the pair plot that we're making. And this samples a 2D plot and a bell curve of all the distributions of the features. So in this case, we have the sepal length and width and the petal length and width. And we can kind of see what this looks like in all the different plotting. So we can come back to this more if people want later. But that's what I was like, I thought I didn't initialize it. So we're making that, we put in the metrics tab, and then we also imported a little function I made that just converts everything to base64. So images to base64, they can be embedded directly into HTML. And then this is also kind of cool. If you are running this locally, like I mentioned, sometimes you might want to do something just when you're doing it local versus when you're doing it remote. So this is one of the ways you can kind of quickly check, like, does an execution ID exist? If not, then do this, and this would be only executed when you're running it without that remote flag. And then we're just returning the 2 data frames. So that's our data workflow. And then after that, we had our training. And we're going to scroll down. We have some artifacts again that we're passing through. And then we have our training task. This one doesn't really have anything new. It's taking the same image. And then here, we're not training a super robust model where we need GPUs or anything. So again, we're actually fine with just 2 CPUs, 2 gigabytes of memory. And we're going to train our model. We're passing in our dataset artifact, and it's going to be returning a k-neighbors classifier model. So we take in that data set, and then we're calling, we're initializing our k-neighbors classifier with the number of neighbors that we passed in. So remember, by default, it's 3, but you could change this as a parameter when you're rerunning this. Then we're calling model.fit. That's the actual kind of training piece here. And then we're returning our model and creating an artifact from it. So we can now have this trained model that exists, and we can like query it, and it's going to be versioned, and we can see the lineage of where it's being used. Actually, if I go to my execution tab right now, so this is a task where that was created. You can see that the output is actually this K&N model. You can click on it in the UI, and it brings you to this artifact tab that you can also click on. It gives you an overview of it. What the object is, you can add a card. So this is a way for you to add more detailed information, but you can also click and see lineage. So we can see that this model came from this workflow and then now exists here. When we start using it in other workflows, which we will hear in a second, to do predictions, you'll see this lineage extend. So it's a really easy way to kind of keep track of, like, where did this data go? Where did it come from? Or in this case, model, and where is it being used at? And then you can click into these and go back to that workflow, saying when we use it somewhere else, and click in and see like how it was generated. So really useful for keeping track of your data and model and like how it's being used in production. And then just a couple more things to go over in our workflow here. After we train our model, we have this evaluate.py. And this is just taking in the model in our test data set. And then basically we're getting the prediction on that holdout test data. And then we're going to see how right it was with the actual test targets here. And we're going to create something called a confusion matrix, which is that kind of plot that we saw. And when I pull this up, looks like, we go back to our execution. When I pull up that in the deck here, again, we're going to embed everything. It looks like this. And so this is a good way to kind of see, in this case, our model was 100% correct, but when it's wrong on stuff, you can see, for this one, it's supposed to be class 0, but it predicted a class of 2. It's kind of interesting and a cool way to see where your model was going wrong on what classes. And then we also have this classification report that we create that tells us the precision, the recall, the F1 score, the accuracy. Again, our model is 100% accurate. In this case, it's kind of a toy data set that's pretty clean, and then our model actually did a really good job at predicting it. So we're creating decks again for the classification report and the confusion matrix. and you'll see a little bit of HTML in here. So again, you can embed any HTML or Markdown directly in those tasks. And I see someone in the chat said, cool, data lineage is really helpful. Yeah, it's awesome. And especially when you have artifacts and models and data, being able to click in and kind of drill down and click directly back into the workflows is really useful. One other file before we go into kind of now using our model that's trained is we have this predict file. And actually, this is going to come up again because we're going to use what's in here outside of just this workflow in a minute. So we have a couple tasks in here. One is batch prediction. So this is actually called at the end of our pipeline here, and it just uses a normal container like the rest of our pipeline. So it's getting that container image, and then we're requesting resources. Again, we don't need anything for here, but if you were using a deep learning model, you want some sort of GPU. Where then we have our, I don't know why the highlight thing keeps coming up. It's kind of annoying. We have our function we're defining, patch knn predict, takes in some data that we're going to pass it, which is a list of floats or a list of floats. And it's going to be a k nearest neighbor classifier coming in as well as the model type. And then it's going to return an int. So you saw those 0, 1, and 2 are going to be returned. Those relate to the classes of our data set. We could add another list in here to actually return the classification names. Maybe I should do that next time. And then we're going to get the predictions from our model.predict. We're going to pass in that new data, and it's going to give us one of those classes and return that as a list back to us. And that is what's called at the end of our pipeline. I'm going to come back to these ones a little bit later, but there's something called actors, which is a long-running stateful container. And we're going to see how this can kind of help us serve more near real-time than a normal container here. So now that we have our whole pipeline, was anyone able to run everything here? So if we wanted to, it should hopefully all be green for you. Again, you can run this all from the CLI or from the SDK, but you can also rerun it from the UI here. So again, if you wanted to do hyperparameter optimization, you could test that out and maybe pass in 4 or 5 and see how the model, the k nearest neighbors model performs in this case with different hyperparameters. In this case, let's go look at just this task, this batch knn, and we see the inputs here was this list that we gave it, and the output was 1. So predicted that this belongs to class of 1. Let's rerun just this task and pass in new data. So we can do that. It's looking at this model URI that's already there from our run. Then we could pass in a list of a list. So we could create a list here containing these values. So these are just 4 values. And what if I put in some really crazy numbers? I'll put really high ones, and maybe I'll put a -1 here, and let's see what happens. Let's do a high one for this last one as well. I'm going to hit relaunch, and now we're running just that prediction task and passing in new data. So kind of like our model served in a way. We had the URI for it. We're able to pull it back into a task and then run a prediction. And this should go pretty fast here. So this node view that you're on by default, I like the graph view if it's a simple enough workflow to kind of see everything. And then you have a timeline view of like how long every single task took to run there. So our task is already done. It's just that prediction task. I can click into it. I can see our inputs were what we passed it. And then our outputs, it predicted it would belong to class 2. And the reason why is, if you kind of remember from our slides, or maybe you're already familiar with machine learning or the KNN model, is, we passed in some crazy numbers that were way outside of here. So this is actually the iris data set plotted here as well. So this would be like way outside of the realm of distribution. And the reason why it still gives us a prediction is it's just giving us the closest 3 neighbors in the case of our model. We don't have any guardrails or anything to say, make sure that it's within this certain amount. Like we gave it a negative number. You probably shouldn't be able to have a negative measurement for a petal length. So you'd want to add in some stuff that can check for data quality like that as well. We actually have a open source tool called Pandera that's really good for stuff like that. All right, so we went through, we built our pipeline. We actually reran our prediction now as well. Let me go bring up the notebook part again. All right, so again, was anyone able to run that whole pipeline and get results from it? Someone said it would be probably helpful, I think it's a missing word, if you could double click on an artifact and hand over between data engineering teams and ML engineering teams. Yeah, there might be some stuff. We're actually working on some UI features about like building pipeline stuff in the UI. Most people seem to actually like writing the Python code. So I'll actually show you right in this next part, or actually right after this next code part, how we do that with artifacts. Actually, I'll bring it up real quick before we run the next part. Again, was anyone able to follow along and build that production pipeline? So we'll see this here in a minute. We're going to run these prediction workflows, and actually the one that we ran here. Oh, sorry. I want to bring up workflows. That's why. So we have these two different workflows we're going to run here in a second. Instead of just running a single task, we're going to rerun a whole workflow. And you can add more tasks to these workflows. So some people that use like Union or just models in general, you might have more complex things than just querying a model. You might want to do pre-processing of data, then query a model, etc. So you actually might want to rerun whole workflows kind of instead of just a simple inference on a model. So in this workflow, which we'll be using here in a minute, if you're sticking around, I know we're at our hour. What it does is it takes in a k neighbors classifier. And if we don't pass in a model artifact, it's actually going to call knn model artifact.query. And then this is going to query for the latest version of that artifact that we created with that name. So it is a really easy way to pass off. It's not a double click in the UI, but if you know where these artifacts are or what their names are, now you can just call knn model artifact.query and know that's going to bring in the latest one. You can also bring in different versions and give it versioning as well. But if you have a data team, like we were saying, and as an ML team, you always want to make sure you're getting the latest data set there. You can just call this query on your artifact, and then it'll pull it in, which is really useful. I don't know if that answered your question where you were talking about passing off artifacts, but that's how it's done here. All right, so a little bit more that we're going to go through. Now that we had our workflow run in the cloud, I'm going to show you kind of how to do everything we just did in the UI. Like you can look at all of our executions, get the information from them. We looked at some of the artifacts they generated. You can do that with the Python SDK and using something called Union Remote. So here we're just going to connect to Union Remote. We're going to create a function which is getting the latest execution model. And so it's going to look at the last 100 in this case. You probably have less runs than that. And what it's going to do is get all the recent executions, look at the last 100, like I said, and then for each of them in there, it's going to see if they match this name, and then it's going to pull the latest version of it. And then from there, we're going to get the model URI from that specific version. So if you wanted to, you could pass in different versions here, but this is to get that model URI that we saw in the URL. So if we run this, we should get that, and then I can print out, this is where my model lives. And then we're going to create another function here that is going to fetch a task name, which is that one that we just did in the UI here, batch knn predict. And then we're going to pass in these inputs, the prediction data and the URI of that model, and get a response back from it. So let's go ahead and run this 2 times. And you'll notice something. So I already kind of showed you the preview of artifacts, which makes this way easier. In this case, we're using kind of just this default way of using the Python SDK, which is how you would do this in Flyte right now, which doesn't have the built-in artifact management like Union. So you're passing data out of functions and then kind of storing that. With artifacts like we saw, we're able to query this and actually kind of do this in an easier way with lineage. So we'll do that right in our next spot here. But just want to show that there's the Python SDK that's really robust. And you can kind of do all those things that we could see or you could imagine doing in the UI with like Python in your code pragmatically if you wanted. So here we got a prediction from that number that we just passed in, belongs to class 0. And then this should take only 30 seconds or so to spin up. Our container is pretty lightweight, so it actually is pretty quick to spin up and give us prediction back. All right, so we're going to go to the last section here, is called model serving and artifacts. So in Union, there's kind of, if you're actually serving from our platform, a few different ways you could do it. You could use regular containers, just like we did above, except for the better way would be with artifacts, like we're going to see here. But it spins up a container, and then that could take a little bit of time. Today it doesn't, because we have really lightweight machine learning library. But if you're using something like transformers and you have to download specific models into your container, it could take like several minutes, or sometimes quite a bit of time to set up that container, run a prediction, and then spin it down. And then, so if you're doing this repeatedly, you might want to not use a regular container for it. But if you are using just it for batch inference, and you're okay with it taking several minutes to spin up, then you could keep it that way, and that could be totally fine. Another way is you can use actors. So I've mentioned them a couple times, and we'll see them in action here, and I'll dive into the code for that in a little bit. But they're a long-running stateful container. So we can spin up that container, and then we give it a value of time to life. So we could say, hey, container, now you're up, and you're going to stay up for 5 minutes after someone's done like querying you. So it'll stay up, you can query it, get a prediction, and it's going to wait 5 minutes before spinning back down. And if you query it again, it resets at 5 minutes. So it's going to stay up kind of forever as it's being queried. And then when it's done, like if it hasn't been queried in 5 minutes, then it's going to spin back down. And so this is really useful, one, for serving, but also if you have a pipeline where you're maybe not serving a model, but you're using the same container across all the different tasks, and the container startup time is quite a bit, and you want it to run faster, you could actually have an actor set as the container for all the nodes in the pipeline in your workflow, and then use that across. So if it's something where you really want to cut down cold start time on containers, Union actors is the thing to look at, and it enables to do something like a near real-time inference for a lot of models. And then coming soon, this isn't out on serverless yet, we have a model serving and model and application serving. So you'll actually be able to build an app in like Radio or Streamlit or really anything you want, and then be able to serve that whole application in Union. So if you kind of like what you saw today, where you have this little declarative infrastructure and then it scales up for you and it handles everything, you'll be able to do that with full application soon. Probably in the next, I don't have an exact date of when it's going to be on serverless, but pretty soon. And I'm really excited to show in a workshop, so you actually come away with a fully hosted model that you could probably share with people and actually have an application running on it. Today, we're going to look at the first two, the batch prediction ML workflow. So this is similar like we did before, but instead of calling that task that was in our workflow separately, we have now a workflow for it. And it's actually the one I brought up a little bit ago that showed the query for the artifact. So I'll show it again. But first, we can run Union register workflows. So before, we've been running Union run workflows, and that registers them and then runs them. They should be registered already for you since we used Union run before. But instead of using Union run, you could use Union register. This is now going to register those workflows, store them in Union, and then you could call them when you want. So if you didn't want to run it right away, you could create those workflows, and then you can also set up schedulers. So maybe they're workflows you want to run, every 24 hours or every day at a certain time. You can also set up triggers so that if data changes in a folder or something like that, then it kicks off those workflows. So you might want to register, maybe not run it first, and then wait for something to trigger it. So now we registered our workflow, and if we go open up our workflow file again, should be the last one I think we have to look at here probably. Maybe the containers one again too. This is the batch prediction KNN. So again, we're taking a model, and if we don't pass in an artifact or pass in a model, it's going to query the artifact, and then we're going to be able to pass in data. By default, it's this data. We could pass in new data if you wanted on this workflow. And then we're just getting the prediction returned, and we're just going to return that value. So if I go back here, instead of just running it like we did before, we're now going to use Union Remote. And this is kind of how you could put this into an application as well. So here we're creating a prediction function, takes data in as an input, and then it's going to pass this input JSON into the task that we're going to call. So we're fetching, or workflow, we're fetching this workflow. So this is the name of the workflow that we just saw. and then it lives in the workflows folder, and it's in workflows.py. So that's why there's 2 workflows here, and then the actual function name. Then we're getting our remote execute workflow, so that name, and then we're going to pass an input, and then we have this wait equals true. So it's going to block this cell from finishing until it's done running, and then it's going to return the output 0, which we only have 1 output, but if you had more than 1, you would have output 0, output 1, etc. And then let's go ahead and run this and print what we get out. So predict with a container, and then it's going to take 30 seconds or so to get a prediction here. If we go to our executions and maybe hit refresh, we have it's blue. That means it's something that's working on in progress. We can click in it, and it's already done by the time I clicked in here. And we could see this was the input list that we passed, and this is the output, which was 0 in this case. And if I go back to my notebook, you can see there's a lag between the task being done in the UI and then actually coming over to the notebook. So with a collab right now and querying union containers, I think it's often like 30 seconds, even if the container is done much faster. You'll see the output 0 is there. So now let's do a similar thing, but with actors. So like I mentioned, actors are long-running stateful containers. So let's go ahead and run this, and then I'll walk through the code. This code is very similar to above, except for we're just calling a different workflow. So I'm going to pull up this workflow as this is running, and I'm going to run this 3 times after with, you could change the values here if you wanted as well. So while that's running, let's go back to our .py files. And in our workflows, we now have this workflow. Actor prediction KNN, which is kind of similar to above. It takes in a model artifact, so it's going to query for it, and then it runs on a different container though. So it's hard to tell from this workflow thing, but if we go to tasks again and we go to predict.py, we have a couple things with this actor decorator on it. And the actor is actually something we created in this containers.py. So it's a special kind of environment. Like I said, it's a long running stateful container. You can give it a name, give it the compute resources, kind of like we did in decorators before, but you put them here instead. And then you have the time to life. So in this case, this is going to stay up for 2 minutes. This is in seconds. You can increase this to be much longer or much shorter, depending on what your need is. Then we import that in our file, just like we imported image before. We imported actor. And then we have this actor task, which is going to, I might have messed up here and left 2 tasks in here. It's okay, it works for this workshop. I think I meant to get rid of one of these, and we should have just this actor model. Or maybe, yeah, let me see actually. Maybe I forget it because I did updates recently and I forget if I did this correctly or not. Basically, we have this actor that we imported, and then we create a special task in there, and we're loading in the KNN and then getting the predictions just like before. And oh yeah, so I think we're calling, I forget if we're calling the right one. That's it. I have 2 different tasks here. They're doing basically the same thing, except for one I created that isn't super useful for our use case today, but it's actually how I use actors to query something like a large language model where they take a lot longer to load. So again, this is stateful container. So in our case, it's going to spin up, stay up for 2 minutes. I had a project where I was using an LM and I wanted to stay up for like 5 minutes. And there's a way where you can preload a model. So if you have a large model, this matters a lot on spin up time. Every time you call the actor, the container spun up, but then every time you do an action, like it was loading a model, it might have to do that thing again, unless you use something called actor cache, which is really useful for that. So in this case, it's preloading the KNN model. Not really useful here because it only takes a few seconds anyway. But if you're using something like an LLM, this is really useful. And then it's going to preload that, and then you can just load it into the actor task from cache. I forget if I'm actually calling the right one in our thing. Again, it doesn't really matter for today. And if I go back to my execution part in the notebook, it's all done for me. And we can see the first one spun up. It took a minute. The other ones took 32 seconds. Like I mentioned, basically the smallest amount I think you're going to get from pinging the direct containers in Union is like 31 seconds, but let's go look at how fast they executed in our executions. So every time we called the container before, it was like 13 seconds or 32 seconds or something like that. Here we saw the first spin up was 32 seconds. And then because the environment, that container was already spun up, it didn't have to spin up again. We're just calling it over and over again for those last two. So it just took 2 seconds for that query, and it only took 1 second for the last one. So that container was up, and it doesn't have to load all of the images or the models or anything like that. And then you can just query and get prediction results from it really fast. So it's kind of a way that you can serve in, like I say, maybe not quite real time, but near real time. And if you need like fast batch inference, it's a really good method for it. And like I had mentioned, full app serving is coming very soon. I'm very excited to show that off super soon. If you did want to take what we did with actors here, you could wrap this in like a Gradio app and put it on a Hugging Face space and have a callable workflow, which would be cool. I've actually done that before. And if you do that, you need to get a Union API key. You don't have to run this right now, but I just want to mention this is how you can get it. So you need an API key. So instead of authorizing like we did in our notebook with the Union create login, you can get an API key and then have other apps authorized that way as well. With that, that's kind of the end of the workshop. Obviously, you can learn way more about building AI pipelines. There's a lot more in the documentation. We have a lot on blogs. I can get a link real quick for my next workshop too, which is going to be on fine-tuning LLMs. But for now, that's kind of the end of the material here, and would love to know, for the people still here, which I still see quite a few, what do you think? Were you able to follow along? Does this seem cool? Does this seem interesting? Are you going to use it in a project? Like I mentioned, you get the $30 of credit when you signed up, and you probably used maybe a couple pennies of it, probably for the workflows today. But if you use GPUs, like there's access to GPUs here. So if you want to do something like fine tuning a large language model, that's actually what I will be showing off in the next workshop. Someone said, phew, that's a lot of content and live walkthrough. Yeah, it's a lot to go through. So obviously also don't feel like, wow, this might have been, or don't feel like bad if it felt like a lot. It's a lot that we went through just in about an hour. Like we covered a lot of concepts for building production ML pipelines. So definitely don't feel like weird if it felt like a lot to you. That is a lot to go through. And depending on your familiarity with Python or machine learning, it also could have felt like a lot just looking at the code. But you were able to run everything. And again, like the way I like to learn is sometimes go a little over my head and then go back and look at the code and ask questions. So if you have any questions later, like I mentioned, you should join our Slack channel as well. And I'm in there, a lot of other people too, not just me. So if you have any questions about anything you saw today or just ML stuff in general, it's a good place to ask. Said, great session, very engaging. Thanks a lot once again. Absolutely, my pleasure. Thank you so much for coming and being the most engaging in chat. That makes it way better for me, and also is a good signal of like, it worked or not. So I saw quite a few people here, but the chat was somewhat quiet today. Sometimes people are just following along or watching and not in the chat, and that's fine too. But it is fantastic for me to have some people say hello in the chat. So I want to say thank you. Absolutely, my pleasure. Hopefully you found it interesting. Did anyone learn anything new, like a new concept, or maybe you've never done this before and now you kind of have an idea of how to get started? And I'll stick around for a couple more minutes, but I know I do have to go do some other work as well. So again, if you do have any questions later, find me in the Slack channel or on LinkedIn. But the Slack is good because it's not just me in there too, so other people can help answer the questions. Also, if you have ideas for what else you would want to see in a workshop, that would actually be great too. Is there anything you're interested about in machine learning In particular, if it could be something like in a pipeline like this, like you're interested in, what does it look like to do this for fine tuning large language models, for instance? Like I mentioned, we're going to do that soon, but any other types of pipelines? One thing I want to work on too is showing some examples of like RAG, building a RAG pipeline. So retrieval augmented generation for LMs. That's where you have LMs be able to interact with external information. We can build a pipeline to download data, create a vector database or create embeddings and then store those in a vector database, and then how to query that either in actors or I think serving will be out soon, like I'd mentioned. So you'll actually be able to see build a full app probably interacting with a vector database would be cool. I've also done some computer vision examples before, and I think I'll probably do more of those again if people find that interesting. We build a object detection model, showing kind of how to bring in your own custom data too. So I actually I'll go a little bit into data annotation, but you won't actually have to do it for the workshop. But the idea is that you could go annotate your own data and then run a pipeline, again, reproducible pipeline that you could run over and over again with new data and be able to train your own object detection model. I think is a really cool thing to do. All right, if there are no more questions, I'll go ahead and end the stream, but hopefully I will see some of you again soon and talk to you in Slack or something. I'll talk to you all later. See you later.